Hello and welcome everybody to a very special Nemotron Labs live stream where we are joining you live from Seoul, South Korea. We are very excited for this, and we're joined by a very special guest, our host today, Changlan. Changlan, take it away.
Hi, I'm Changran. Thank you for coming here. Thank you for visiting Korea, and we are having a first live stream in Seoul, right?
First of many, I hope. Yes. So over the last few days, we have been here to do something called the Nemotron Developer Day, which has been very exciting so far.
Yeah, deep dive.
Go ahead.
Deep dive sessions from the HQ NVIDIA researchers, including Brian BP as well.
So, that's right. Brian Catanzaro made an appearance. It was pretty epic.
Yeah.
We're going to get more into that in just a second, guys. But in order to set up kind of the vibe of what it was like here over the last few days, we're going to kick off to a video that showcased what the first day of that developer day looked like. So Zach, if you want to go ahead and play that video.
Cool.
Very cool. Very cool. It was a lot of fun to be there.
Yeah.
A lot of very interesting projects that we saw over the few days. Chala, tell us a little bit about, how you set this up and kind of like what the idea was to bring as much energy and kind of the vibe of Nemotron to the good people of Seoul.
Yeah, actually, Korea is one of the most important country about sovereign AI, because we are building models from the scratch, and there are a lot of model builders about fine tuning or post training as well. So and especially we have many industries, including manufacturing. So there are a lot of area we can apply our Nemotron ecosystem. So we prepared the deep dive sessions, and we had a hackathon, and we had a builder class session. So it was amazing, full of Nemotron everything, like model and SDKs and training strategies, and even NeMo-RL, right?
That's right. Yeah, I mean, it was a lot of fun just to see everybody building with Nemotron or the NVIDIA ecosystem, of course. But it was also so exciting to see how passionate and skilled the Korean devs are when it comes to leveraging technology. We had a lot of people join for the Build a Claw event, where they were getting kind of started with claws on their own hardware or using cloud instances. At the end of the day, I think this was a incredible experience for people to join. Guys, don't forget, if you have any questions for any of the people that you're going to see here today, don't forget to drop them in the chat. We're going to be having some presentations, and so when we have those, please feel free to ask the presenters any questions that you have. Charlon, one of the things that I noticed during the deep dive sessions, right, is that a lot of people were not just like listening and nodding along, but taking notes. Really, they had really great questions afterwards. How do you think people are adopting AI in Korea? And how do you think that impacts how us as NVIDIA need to communicate to the Korean developers?
Actually, some of them are building their own model, or some of them are using AI for building agents. But this time we had a really deep dive session. So during that, I think when we are just building our AI model or agents, sometimes we are competing with other companies. Like, we are developers, we know opening our model or source or strategy is important, but in company it's really difficult to open our knowledge. So, but in this event, we shared all of our NVIDIA strategy for training models. So it was really, really impressed by Korean developers. I heard a lot of uh, recommendation or reviews from them, and I'm really excited about that experience.
Yeah, it was really cool. And I mean, what was also cool, obviously, was the hackathon.
Mm-hmm.
Seeing so many people building with tools over 48 hours, and the projects were extraordinarily ambitious.
Yeah.
And not just ambitious, but like they kind of like got her done. We're actually gonna see some of these teams who won.
Yeah.
So can you outline for us a little bit like what the hackathon structure was? You know, there's this idea of 3 tracks. Do you mind like outlining what that was all about?
Yeah. Actually, we had 2 days for the hackathon. It was really, really short time to do, but we planned 3 stacks, including creating a builder agent creative use case and fine-tuning models and create a data set. So synthesize the data set. So it was really short time to do that, but everyone made really great project, and they will bring to their company or their individual projects after the hackathon as well.
Yeah, it was really incredible to see the amount of work that all of the teams were able to do. We're going to see the winners today, and we're going to get a chance to see their presentation, what they actually created.
Yeah.
But I do want to say that all of the projects were strong. It was a hard decision to determine the winners because there was so much talent over that 48 hours. And I was just absolutely astounded by the level of ambition and kind of greatness of the projects. But we've got the 3 best projects that we saw at the hackathon here, one from each track. And so we're actually going to get our first guest up. Do you mind introducing them?
Yeah, he's from Naver, and they made a creative agent. Please join us.
Yes. Zach, if we can get that picture up showing them holding the spark wooden.
Yeah.
Hi, I'm Hansu, and I'm from Naver.
Is it slide on, Jack?
You're good.
Yeah.
You're good.
Okay. Please introduce yourselves.
Okay, my name is Hansu, and you can call me just Hansu. I've been working at Naver as an AI engineer, and I'm very glad to share my experience about my hackathon. So I'm glad to see you.
Yeah, we can just start with your stuff. Please introduce your projects.
Okay. My project is the NeMo briefing. The NeMo means the new model. So NeMo briefing is an AI agent to collect the users' reactions and summarize and deliver the report about that. So I started. Okay, first I will introduce my team and my company, and I've joined this hackathon with my awesome teammates Sangjin and Ingon. They are very awesome AI developers, and so let's introduce our company. The Naver is the biggest IT company in South Korea and the competitor to Google in search engine. We have a lot of many business models such as Place or B2B or AI or cloud. So let's start it. Our key idea is started from our internal work project. We built some leaderboard to evaluate various LLMs, their accuracy and performance. But we found that there is a significant gap between the benchmark score and the real users' reactions. So we thought it was really good to build some AI agent to collect the real users' feedback and reactions and add them to our leaderboard. So we started it. Yeah, it's our architecture of NeMo briefing. First, we build a query generator agent for refining the query and for the high quality search result. So the second part is the corrector agent, and it is our key point. And inside each corrector, we had a validator, and validator filter out the unnecessary items. And we correct various from the various source such as Reddit, Lobsters, or Hugging Face community. And the final part is the reporter agent. A reporter agent just aggregate the whole data and summarize them as a markdown report. Now, this whole part is orchestrated by Nemotron 3 model with React prompt. So we used every NVIDIA stacks in our project. First, we use Nemotron 3 model. We use super model for difficult tasks such as React or validation. And we use nano model for simple tasks such as query generation. And these models are deployed on Brave Cloud and with the NIM Docker image. It is really useful and easy to use. And we developed our agent with NeMo agent toolkit and known as NAT. I think it is really awesome framework. I've used other agent frames such as LangChain or ADK, but it is really cool and easy to use and extendable. I really like it, this configuration. So let's see the demo video. I searched the Nemotron 3 support model and query generator starts and skip them. The data collector works, but in the parallel, and they collect each data and validate them in parallel. So I'll skip it. The final section is reporter. It takes some long time, so I skip them. This is a final report. So let's type in the example report about the Nemotron 3 support model. The reports say that some users have some trouble in the configuring the reasoning mode, but I think it is not the model problem. It's just about the issue with the framework or template. But it is really useful to catch this gap with early time. I think NeMo briefing can help this. Okay, the final section, and we don't have much time. It is a hackathon, and 36 hours isn't enough. So here is the future work, but I will skip them. It is not important. Okay, I'm done.
Great, great project. This was the winner of the track A. Do you have any questions? Please shout out the text. Hello. Congrats, Hansu and team. Great demo. Yeah. During the hackathon, you met NVIDIA researchers and you had a great mentoring. Any great experience from that?
Okay, they helped me. They helped our team to select the topic, the proper topic, and make the right architecture at the proper time. Their advice is really helpful for me.
Yeah, thank you. And actually, NeMo is a neural models, but neural models. But you saw the new model, right?
Right.
Yeah. Why did you think like that?
Because our project is to correct the user reaction from the new model, about new models. So we use the NeMo.
Are you going to use it for the automatically like agents, right?
Right.
For your company research or some?
Yes, I've developed some agent in our company, such as AI National Agent.
You will open to public, or you will use it on your company only?
It released at March in this year. You can use it neighbor, and everyone can use it. It's great for the government.
I see. It's great for researchers, I think, all model builders or model users. Thank you for the great project. Thank you, Hansu. So we are gonna move to next track B. The winner was from the pilot. Can you join us? Jack, please show the winner's image. Thank you. Oh, I didn't mention the important thing. Uh, Actually, the prize was the Spark. So the you can see the spark on the image, right? Yeah. Thank you. Thank you for
Yeah.
coming in. Please introduce yourself.
Yeah. Hello, I'm from Pilot AI, and my name is Jungso Kim. And we win in the track B about the fine tuning open source Nemotron model. Yeah.
Thank you. Please introduce your project as well.
Yeah. Okay. Let me start. Hello, everyone. I'm from Pilot AI, and today I'll talk about the fine-tune NVIDIA's Nemotron Nano into a fine-grained, trustworthy video understanding model for content safety. So when you ask a model to classify a video for safety, you will really have two choices. First, you can feed the whole video at once and get a single label, but in this case, you lose any sense of when the harmful content actually appears. Or you can split the video into chunks and analyze each one, which give you fine-grained, temporally grounded results. We want to see how much this second approach changed model behavior and how far we can push it with fine-tuning. For data, we build our training set on top of SafeWatch, which published in iClear 2025. That gives us about 8,000 videos and 25K chunks for training, plus a test set of 1,200 videos with video level descriptions and labels. So our first step is supervised fine-tuning. We run both LoRa and full fine-tuning on Nemotron Nano's 12E V2VL model using the Megatron Bridge SFT pipeline. The goal is to teach the model to produce chunk-level explanations instead of a single video-level summary. For post-training, we wanted to do preference optimizations. But NeMo-RL doesn't officially support the Nemotron Nano V2VL yet, so we implement simple and DPU ourselves directly on the top of Megatron Bridge. Due to time constraint, the results I'm sharing today are from simple training method. The reasoning of this preference optimization is open source models already do a reasonable job on whole video understanding, but they struggle with temporal grounding. So we use segment level temporally grounded output as the winning data and whole video only description as the losing data. Yeah, so for evaluation, we put together 3 benchmarks. First, we split SafeWatch training set into train and evaluation dataset using TraceNet for temporal grounding. The second, because the SafeWatch test set only has video level description, we use NVIDIA's AI Blueprint VSS to pseudo labeling the chunk level explanations and classifications. And finally, to stress test longer videos, we take video MME clips and inject harmful segment in the middle, so the model have to quickly temporally ground the injected portion. We evaluated on 2 metrics. First is average F1 for accuracy, and second TIOU for the temporal grounding ability. So our baseline pipeline is straightforward. Nemotron served by a VLM takes the whole video in one shot and outputs 3 things: the description and guardrail label and 6 categories and explanation. So the baseline results on the open source model is like Quantum 5.5 VL is like a approach 0.318. Finally, the Nano 12B V2VL model showed the best performance on SafeWatch benchmark. So our approach at chunk level inference on top here. We train a Megatron Bridge expert to Hugging Face and start with VLM. For each temporal chunk, the model emits a description, guardrail labels, and an explanation. Yeah, so on the SafeWatch evaluation split, the baseline Nemotron sit as 0.5 or about 0.5 F1. The chunk level prompting alone jumped at that to 0.75. The LoRa SFT more pushed the performance of this model, and finally the fine-tuning with the full fine-tuning with chunk level approached the best performance on temporal grounding. However, about the accuracy, it degrade the performance, but we should find more accurate hyperparameter. And for temporal grounding results, when for full fine-tuning and LoRa also increase the performance of TIOU, and also reinforcement learning also increased our performance too. And this is our qualitative example. So we cannot show the exact safe was sample directly. The content is genuinely harmful. So you can see our model localized the harmful segment much more precisely than the baseline. Yeah, finally, our everything source is open source now. The supervised fine-tuning pipeline and Megatron Bridge RL post-training code and the full toolkit, data creation, VLM inference, evaluation, and visualizing web demo, all is on our GitHub repo. So if you're interested in here, please visit our webpage. So thank you.
Oh, thank you. Wow, you shared all codes. I think it's really valuable for all communities.
Yeah.
If you have any questions, please write the questions in the comments, please. I will start with my questions first. Do you have any tried new thing? What have you have not done in your company before during hackathon?
Yeah, so in our actually temporal grounding ability is hard to inject in MLM model. So we should divide the chunk level approach first, like the translate or other architecture for dividing the scene. But in this case, we use just single forward for chunking level approach in the like a chunk level description and the chunk level guideline. So we think like, firstly, we think like exactly MLM can do this only in single forward pass, but when we fine tuning with the appropriate data, we can achieve some temporal grounding accuracy and guideline performance too.
Yeah, thank you. And you analyzed about the videos. So is there any interesting video you filtered or something like that?
Yeah, so there are very many harmful video, and I will talk about like Megatron Bridge mode. When we train on Megatron Bridge, if it is not trained with Megatron Bridge, then the training the model and also like a loading data and all kind of pipeline is like there are a lot of bottleneck on the loading model or loading data. But when we train on the Megatron Bridge with the MV codec or many NVIDIA stack, then we can use really efficient pipeline for training video and also on the inference pipeline too.
Great.
Yeah.
So you have only 2 days.
Yeah.
Do you have any strategy to train a model? Because training a model during 2 days is sick, right?
Yeah. It's very sick, but like very thankfully, like NVIDIA give like a little more GPU for track B participants, so we should fine tune the model. So yeah, we use the one node of H100 for 2 days. That's a really expensive and also very good our resource, so we can fine tune our model, and we should find more appropriate hyperparameter too. But like, yeah, we can do some kind of baseline approach here. Yeah.
Yeah, thank you. If you have 1 more day or 2 more days, what you want to do?
Yeah, we should find the appropriate parameter for achieve temporal grounding and accuracy at once, because now our parameter can achieve only temporal grounding performance now. So yeah, we should find that more now. Yeah.
Thank you. Yeah. He was the winner of the track B of the Nemotron Hackathon. Thank you. And we are gonna invite the winner of the track C, and especially the winner is the all of the hackathon as one thing. So please join us. And please show the image of the winners. Yeah. Yeah, winner is here. The team is from the Nota AI. Please introduce yourself.
Hello, everyone. I'm Hancho Park from Nota AI, the world's best AI model optimization company, hopefully. Thank you for inviting me. I work as a tech lead in our company. So, okay. In the hackathon, we propose a novel MOE quantization method in the perspective of the data set. We call our pipeline as Pascal MOE, which stands for Pipeline for Activation Balanced and Sensitivity Aware Calibration Set Generation for MOE quantization. As you know, modern LLMs increasingly adapt MOE architecture because of its computational efficiency. However, the memory usage is remain high, making the lower precision quantization method is required. However, existing quantization methods do not consider the following MOE-specific characteristics. First, some experts are rarely activated during calibration, resulting in poor activation statistics, which naturally lead to large quantization errors. The second is quantization sensitivity experts must also be sufficiently covered. The figure below describes the problem. So we hypothesize that more balanced experts activate during calibration may reduce the quantization error by improving activation statistics for most experts. So naturally, our goal is to develop the pipeline to synthesize samples that better cover underutilized experts. We also hypothesize that more frequent activation of quantization sensitivity experts may reduce quantization error by improving the accuracy of their activation statistics. Our pipeline will be generate the samples that frequently activate quantization sensitive experts. This slide shows our proposed method. The proposed method seems quite complicated, but it's quite straightforward. First, our pipeline investigated the target experts, which either frequently activated or sensitive ones using the inference stage. And then using those target experts, we can our system can identify the target tokens. The target token will be a set of context and token pairs. And then we assign the label to the target tokens in the initial the data set like this. With the in the next page, with the pre-designed prompt, with the sample or annotated samples, we can generate it, the patterns which just describe what kinds of the samples the system has to generate. And then we use the NeMo data designer to synthesize the samples that we want with the generated Pascal guideline, and then we replace it on desirable samples with the newly generated samples. This slide shows an example of the output from each page. Interestingly, we observed that intuitively less common or less natural tokens tended to activate underutilized experts, such as backslashes, double backslash. And as you can see, this picture below, the same shading indicate the rules and the synthesized expression that follow the rule. We observed that the generated guideline was very interesting for us. In order to evaluate our proposed pipeline, we quantized the QN3 MOE model using the various kinds of the NVIDIA software stacks. The quantization scheme was int4. We used the GPTQ algorithm. So first, as you can see in this slide, our proposed pipeline generates the more target samples in terms of the exponent balancing or sensitivity experts. This slide shows the very impressive results. Our proposed pipeline outperforms the Nemotron post-training data that has that contain undesirable samples. Although I wanted to show more things, but this is the last page. Thank you for your attention.
Yeah, thank you for your presentation and congratulations again for the
Thank
first
you.
prize.
Yeah.
And actually, this is what we expect during the hackathon exactly, because we can generate something easily in this era with AIs, but for the data set, it must be useful, right? But you made a data set and it is applied to your product as well. So it was really amazing. I want to ask about the experience of NeMo Data Designer.
Yeah. I think that demo data designer is very impressive for us because everything has been naked. We just give the prompt, we just give the guideline, and then the Nemo designer generates so many things, so many samples, which which meet our expectation. So we will use this design, this software later, and we hopefully we wanted to give our method to the I mean contributes to our proposed pipeline to this designer later. Yeah.
Great.
Yeah.
And there is a good question. Skyward Horizon asked about how do you define quantization sensitive experts?
Yeah, it's very important, but I missed it because of the time constraint. Actually, the quantization sensitive during the hackathon, actually there are a lot of definition of the sensitive experts, but we simply define the sensitive expert as the largest magnitude of the weight. I mean, we sorted the maximum magnitude of each weight, and then we define the this experts are very sensitive because the weight magnitude is so high. Yeah, this will be I mean, we in the future work we will propose a method to automatically select the sensitive experts.
Yeah. Really great to hear the details. During the hackathon, there was a great experience. One more thing, because was a demo session, because we shared our knowledge and experience during the hackathon in the demo. So it was really great. And one more good questions. Username hobby75 and 24. Do you think this method will work for other quantization algorithms as well?
Yeah, of course, because as I mentioned before, our method is not just for the algorithm. Is our method is related to the data set itself. So our method can be used any kind of the quantization method.
Yeah, thank you for your attention. Please visit GitHub and you can experience the code as well. So please turn on our sketch video of day 2, Zach, please. We had a great day. Yay!
Yeah, absolutely incredible presentations. I mean, that again, that's imagine that all of the projects that we watched were close to that caliber of presentation. Obviously, these guys won for a reason, but there wasn't a big split between the top the top projects and the next best projects, right?
Yeah.
So we watched 20 or so presentations.
Yeah, right.
And all of them so good.
So good, yeah.
Yeah. We had a bunch of time to hear about the projects and the hackathon. Maybe we'll spend some time though answering some questions from the chat. I saw a few earlier. I also saw some legends from our community, like Cody's Guide to AI. Thanks for coming to the special live stream, guys. We have Also, some comments talking about how good the food is in Korea. I can confirm that the food is extremely good. I have had the pleasure of eating it all week, and I'm a little bit sad to have to go back to Toronto. But I'm gonna make sure to find a good Korean spot there.
Yeah,
So
there might be.
maybe let's scroll up a little bit here in the chat and let's see. I know we had a question early on. Maybe we can talk to that one. Yeah. Okay. So at Hamadraza 1584 asks, how can I use AI agents created with NeMo Agentic Toolkit with actual physical AI agents? Is there any integration with ROS2 operating system? So this is a interesting question, Chanla. I don't know your familiarity, but do you know of any way that we can actually hook these LLM brains up to maybe some arms and legs?
Maybe we can add some skills, and actually agents will build new skills as well. So it is possible, I think, and there are a lot of documents there. So you can easily add some skills with AI.
Yeah, and I think, we do have a lot of this is the Nemotron Labs live stream, so we're kind of focused on the Nemotron series of models, but NVIDIA has a huge array of physical AI models.
Yeah.
We do have a physical AI stream as well that you can check out if you wanted to look at that, where they discuss more about robotics, but things like Groot and Isaac Labs.
Yeah, Cosmos,
of course. If you want to get started with physical AI or transitioning from LLMs to physical AI, lots of great technology for you there. And of course, it's only going to get better. This is the worst that robots will ever be, which is crazy.
Yeah.
We have another few questions. Nemo Squid from Angel Romero. Someone asks, at Board Tomato from YouTube asks, what do you think about the Nemotron challenge? How do I get past 0.84 without training all the linear layers? So this is actually in reference to our Nemotron reasoning challenge that we're running on Kaggle.
Oh, really?
Yes. I mean, there was a midpoint that just happened where the team actually chose the best project so far. And I think that write-up obviously has some great ideas if you wanted to look at that to get a little bit of inspiration. So what are your approaches when you're trying to squeeze the last few drops of juice out of training a model, Chanlan?
For me, just check the data set. Just make a more delicate and good quality of data set. So I should check about the details from there. I analyze it and filtering some bad cases, or I should find the failure cases and add some data set for that as well. So I think the problem is just data set.
I mean, a classic and very good answer.
Yeah.
Look at your data, make it better. If you don't think you can make your data better, you haven't looked at your data enough, right? So
I think it's also like similar to K-food. Like if there is a good ingredient and good mind, it comes out.
There you go. That's the secret. Good ingredients and good minds make good models and good food.
Yeah.
That's good. That's good wisdom for Friday. Cody's Guide to AI asks, how do we open this box up and add the NVIDIA agent toolkit so it refines itself the whole time and stops failing tools? What is the best local model to use for NemoClaw and how to make agents? Cody's Guide to AI, many great questions there. Community legend here. I mean, maybe let's just think about the first one. So, we saw in the first project from Naver this idea that we could build an agentic system to kind of collect feedback. I think Cody's Guide to AI is asking, how do we take that feedback and then roll it back into the technology to make it better over time? What are your thoughts on that, Chanlan?
I'm not sure. Just keep trying, actually, but based on the model, there is ability of the two callings metric as well. So choose great model first and try keep make a great loop for that. If there is a failure, try bait it please made it try again for the great loop, I think.
Yeah, I
How
mean,
about you think?
yeah, I think you hit the nail on the head. I mean, at the end of the day, right? We're seeing more agents do this kind of recursive self-improvement thing, right?
Mhm.
Where like Hermes agent or something like that is
Ah, I
gonna, edit its own
Mhm.
skills, its
Mhm.
own config, its
Mhm.
own even sometimes, you can work with it to enable it to edit the way it's implemented,
Yeah.
right? So it improves over time.
Mhm.
I think though for the first project, the Naver, kind of collect this feedback project, it's really important for companies, right,
Yeah.
to know what people think about their products and where they're finding problems, so that those companies can take those insights and
Mhm.
make the product better, right?
Mhm. Yeah.
I remember on day one talking to the Naver team and say, hey guys, like this is very useful even for us, knowing
Yeah,
what the
right.
community thinks
Yeah.
about our technology,
Yeah.
and if we saw there that someone's struggling with the reasoning feature, what we should do?
Mhm.
We should make it easier, more clear to use the reasoning feature of the model. There you
right.
go.
Yeah.
We're just scrolling through the chat here, guys. So many different. Oh yes, AI career path, RLM or bust. RLM, of course, recursive language model. Some work done by Alex and the MIT SAIL team. Really great research that a lot of people are very excited about. If you haven't heard of it, definitely look into it. Yes. Simon Falk, interesting. Quantization shows where efficiency meets fragility, like biology. It's not just energy, it's how it's structured. That's where intelligence holds. What a comment. Absolutely true, though. Quantization is a big thing. It's a big, as the team described, right? Not an easy task, especially when it comes to MOE.
Mhm.
So you have another question, Chala. Maybe you'd like to read this one.
This one.
Yes. This one.
Oh, have you tested Nemotron Cascade 2 or Nemotron 3 Nano with NeMo-Claw?
Yes.
Here.
Yeah. So NeMo-Claw is the NVIDIA runtime for OpenClaw. We've done a few live streams about it recently, which is why we're getting some questions about it. I would say yesterday and the day before, actually, we were showcasing the model using both, of course, Nemotron 3 Super. I'm very biased, but that's my favorite model. And the Gemma 4, the new Gemma model, both running in through OpenClaw. And then as well, you can run them through NeMo-Claw. So I would say those are great models to start with. In terms of stacking the models, right? We're actually going to have some live stream coming up in a few weeks where we're going to get a little bit into more the weeds on how you might stack models or sub agents with the kind of claw technology. So Cody's Guide to AI, make sure to tune in the future. But Nemotron Cascade 2 and 3 Nano are both great models. I would tend to say that something like Super Caliber is better for the main agent of your claws. And then we're going to use things like Nano and Cascade as sub agents. Are you a big claw guy, Chanlon? Are you are you out there clawing it up?
Yeah, it's I think we are adept with Hermes agents nowadays. So we are really experiencing the self-evolving agents. So as well, but we are having struggle with tokens, right? Yeah, because the token is burning out. So we need our own model sometimes. So we need Spark or some our own cloud or stuff. So you mentioned about Gemma 4 or our models as well, but I want to mention one more stuff for the quantization, because there is a model quantized with NVIDIA for the Gemma model as well. So you should try with that.
Yeah, famously, DGX Spark, right, works great with NVFP4. So any model that's available in NVFP4 format is going to run a little bit better on the Spark. I do think at the end of the day, you know, there's a lot of times that your agent's going to do work that isn't, you don't need to use a lot of expensive tokens.
Yeah, right. You're
Grepping through the file, you know, to find some snippet, or you know, creating a directory, or you know, making a small edit to a code file. We don't need Claude Opus 4.7 for that, right? We can get away with
no Opus.
we can get away with Gemma for that.
Yeah,
So,
yeah, right.
excellent stuff, guys. We have MVFP4 is dope.
Yeah.
Yes,
Dope.
true. What's the best open source to use with NeMo Cloud? What tool fits best with Quantum?
Quantum.
Well,
I've never experienced about that actually.
well, what I can tell you is that NeMo Cloud is designed to work well with all kinds of different things. So obviously, it should work with NVIDIA technology, but it should work with most everything else as well. The idea is to you know, to have a platform that works well with whatever you're using. And if you don't know what you want to use, or you have an idea that we haven't put in yet, please contribute to the repository, contribute to the project. And if you don't know how to contribute to the project, you should check out Tuesday's live stream where we talked all about how you can contribute to open source. You know, if you're like, I have a great idea, I wish it worked with this or that, please contribute it. And if you have a quantum model that isn't yet supported by NeMo Cloud, please submit a PR. It would be
that's
that would be
open
great.
source. Yeah, that's open source.
Yes, I think we have some exciting quantum stuff coming up, but for right now, that support, if you need it, put it in. Yes,
We have some time for waiting for the great comments. I want to mention one more thing.
Yeah, please.
During the hackathon, we had a great session with a meditation.
That's so true.
By Nemotron. Zach, can you please show the image for the meditation session? So we had a meditation with Nemotron.
That's right.
Yeah, Nemotron super generated text for the meditation, especially for the developers. So the text was like, please forget the error messages or the stacked PR, just relaxing. And we had a second day of the morning that we had a meditation. So it was really great. Relaxing, and we can focus on the hackathon after the meditation as well.
That's right. I mean, at the end of the day, Nemotation, exactly. Yes,
Great name.
This from IT Sec on it. Yeah. I mean, listen, hackathons are long. You have to stretch your mind a lot. It's nice to take a little break, a little breather, refocus, recenter, as guided by Nemotron 3 Super, who's a pretty chill guy.
Yeah.
There you go. Also, I think you had voice to or text to speech.
Yeah.
So you could just close your eyes. And if you bring the image back up, Zach, little Easter egg for people who know the developer community team, you'll see in the back left corner there, that's Mark Heat.
You found him.
An absolute legend in the developer community effort here at NVIDIA. So NeMo Zen is great, Raphael. Absolutely great, NeMo Zen.
He was really busy with Build a Close session, right?
Yeah, Build a Cloud was popping off, guys. If you're going to an NVIDIA event in the future and you're wondering all about claws, you can probably find a Build a Claw tent near you that will help you understand this technology a little bit better and get hands-on with it, see some sweet demos. One of the things that I was really excited about, Chanlan, is, you know, here in Korea, you've built a really impressive community of AI practitioners called Pseudo Labs. And they actually showed up and they helped out at the Build a Claw event, showing demos, helping people. So it wasn't just like NVIDIA came to town and all from HQ, like, blah, blah, blah. It was actually local devs from your community that were helping people use and understand this technology. If someone wanted to learn more about Pseudo Labs, so they were excited by what we're doing and they're excited by maybe digging deeper on nights and weekends, where should they go? How do they find Pseudo Labs?
Actually, we are based on Discord, and we are non-profit AI and data science research community. So you can just come on in and you can visit our. There are several rooms and our timetables, so you can just come in and you can have experience about agents or researching LLM models or physical AI as well. It's just there are a lot of projects there, and actually we invite them into our build a close session, but there are all employees from other companies like big enterprise, but they had a PTO for uh, for visiting our session, and not just visiting, helping our session, and they shared about their own agent Clo experience for us. It was amazing, actually.
Yeah, it really was amazing. I mean, these are working professionals that took time off of work to come help out, to help people understand and access this technology better. That's the vibe. That's been the vibe the whole time that we've had the pleasure of being in Korea. It is just absolutely amazing. I can't wait to see what you, Chanlan, and the team that you don't see behind the camera here, guys, get up to keep growing that community and keep helping the kind of AI work being done in Korea to continue. It's been so amazing. We have some slides, guys. We have to pay the slide tax because at the end of the day, these live streams are fun, but there's a whole ecosystem of things you can learn from. So if you're hearing in the track A project, right, you're hearing about agents, but you're not quite sure what they are or what they mean, then you can check out these learning paths at developer.nvidia.com/topic/AI/how to build an AI agent. We've got some updates coming that should make this more related to clause in the near future. Zach, if you go to the next slide, please. We also have, of course, our NVIDIA Nemotron repository. This is where you can find how to run the model, how to build the model from scratch yourself if you wanted to. You might need more than a H100 node in 36 hours, though. But you could build your own Nemotron 3 Super if you wanted to. And then, of course, we've got another slide. If you want to join us at Discord, we've got discord.gg/NVIDIA developer. Once you join that, you can look for the hashtag Nemotron Models channel. You'll be able to find me in there 24/7. Even if you send me a message in Korea time, I'll probably respond pretty quickly because I'm up all night. So, but leave any questions you have in there for us. If you have any questions for the teams, you can also put those in that channel. And I'll make sure that it gets forwarded to Chanlan, who will make sure that it gets forwarded to our incredible winners.
Yeah.
Next slide, please, Zach. If you have any questions for the NVIDIA developer community team, so this is people like Mark Heaps and Zach, please reach out to community@nvidia.com. Zach does live in a cave. It's always dark, and the only screen he has is this email, so he'll answer your question if you send him an email. I'm just kidding. We let him out from time to time. He's not an intern either. He's a real full-time employee, guys. Otherwise, I have one last question for you, Chanlan. Well, we've got about 5 minutes left.
Yeah.
I've enjoyed my time so much here. I've enjoyed getting to meet all of these incredible developers. Every time I get to visit somewhere new, I'm so excited to see how passionate people are about AI. But how did you get into AI? What made you decide what you want to do with your life is AI, and not just learning about it, but then teaching people and sharing it with a community of people? What gets Chanlan out of bed for teaching AI every morning?
Actually, I started with the experience of the Kaggle. Actually, I grew from that community. So every day I see the leaderboard from there, and then I see the improvement, me and the community as well. So nowadays there is a lot of AI stuff in all communities, all internet stuff. And so when I woke up, I just see what's going on today. Like, today also there are big news about AI. So GPT-4.5 is released. So it's like that. If something new AI is coming out, we want to experience all things, right? Yeah, I started with that, and new experience gives me new life, I think. Yeah, that's coming from what I do every day, every morning, and I start from that experience from since AlphaGo. So I every day, every morning, I experience new AI stuff. So with agent, it helps me a lot to experience more and more, and a lot of experience knowledge as well. So it's incredible life and new life, and with NVIDIA community and NVIDIA models, and supported by our GPUs. So it was amazing.
Incredible stuff. Incredible answer. Just what you'd expect from someone who's helping so many developers across the country and the world. One last question in the chat. When is Nemotron Ultra releasing approximately? Thanks so much. It'll come out when it comes out, guys. I know every stream you want to know. It will release when it releases, and I'm sure that we'll tell you. You should expect to see that we announce it. So it won't sneak up on you. You'll know. We'll tell you. Thank you so much for your time today, Chalan.
Yeah.
Thank you for sharing the office with us.
Thank you for coming to Korea here.
Of course. Absolutely amazing. 감사합니다.
감사합니다.
Kaja.
가자.
Kaja. Okay. Thank you, everybody. We will see you next time. Bye.
Bye.
Bye, everybody.